All right. Notice the apples and oranges? All right, let's see. I'm glad I brought my notes because it's not in presenter mode, is it? That's okay. All right, so we're going to start with some general ideas, general things, general tips and concepts related to communicating science, doing outreach. This applies to public outreach. It applies to education too. It applies to basically any kind of communication from scientists or people who the public will think of as scientists, you know, like a science teacher, communicating to an audience at any level. So I'm going to start off with a little bit of good news, which is just that in recent polling of the US population, even up through the current administration, there's some encouraging news. I mean, most people, like 3/4 of US adults, say that they trust scientists to act in the best interest of the public. So that was the specific question that was asked, but generally it's, you know, does the public trust scientists, you know, to tell them the truth, that kind of thing? Generally, yes. It's not just from one survey. There was a paper published in Nature, Human Behavior, just earlier this year, called Trust in Scientists and Their Role in Society. And this was not just in the US, this was worldwide, 68 countries. There's this graph that shows the trust index goes from no trust at 1 to complete trust, implicit trust at 5. And it just shows the numbers for each country. But you can't fit the whole thing on there in one slide, so here's the top part, okay? And the mean is 3.86 out of 5, which is, or 3.62 out of 5, and the US is slightly above the mean, which is nice. That's, again, about 3/4, 75% roughly, of people who trust scientists to tell them the truth, to act in the public's best interest. Now, if you look at other kinds of polling that's done about, you know, whether people trust various professions, you know, this is pretty good. If you ask about politicians, if you asked about journalists even, and many other professions, lawyers, those numbers are not so high. So we're in a pretty good position just coming out of the gate before we've opened our mouths. There is some bad news though. Okay, so a growing fraction of the population, especially in the US lately, you know, is turning against science. And that's not a good thing. I found this wonderful example with an eclipse-related cartoon. Okay, so there's more bad news. This is nothing you don't already know, but a lot of people are getting information from online sources or from other sources that are drowning out, you know, what we used to consider to be the truth. A lot of people don't consider it to be the truth anymore. They call it fake. But with the glut of misinformation, which is information that's wrong but not necessarily intentionally wrong, and disinformation, which is worse, information that is not only wrong but is being given to you purposefully as lies, it's really getting bad. And because of the siloing that social media enhances or you know, makes more and more people get into fewer and fewer silos is bad. So artificial intelligence is now compounding the problem. There were 2 recent studies published just in the last few weeks, one in Science and one in Nature, showing that large language models, which is how most of us are being introduced to artificial intelligence these days, you know, the chatbots, ChatGPT, Gemini, that kind of stuff, that they actually are putting out a high density of false information. It's just because, you know, they were trained on the internet, right? So they're using a high density of fabricated information that is demonstrably producing attitudinal change among the public, okay? So people are going to the polls and voting based on lies. That's what is happening in this country. And it's not only in this country. So what is a science communicator to do? There's plenty of days when I wake up thinking, I want to give up. But I'm not going to give up, and I hope none of you will give up. Thankfully, science itself does have some answers, okay? There is research into the science of science communication. It's done mainly at universities that have communications programs, communications degrees. There are a handful of places where you can get a master's in science communication or science journalism. So these places have faculty who are doing research into how people process scientific information from a variety of sources and how it affects the degree to which they're learning, the degree to which they trust science or feel supportive of science, believe what they read in the press about science, et cetera. So I've scanned through some of the meta papers about this stuff and pulled out 10 findings. I decided not to order them in priority. I'm just going to give you 10 things that you should keep in mind when you are going to communicate science to any audience. Okay, so the first one is that framing matters. Framing issues in ways that align with values and emotions is critical. Focusing on things that relate to human health. So for example, when you're talking about light pollution, talk about its effect on human health or wildlife, community well-being. Those things make scientific information more relatable. It's easier to persuade people of some scientific finding if you can relate it to their lives. Okay? Now you might think in astronomy that's impossible, but it's not, because everybody goes out and looks up at the sky. So everybody has some experience with astronomy. Okay. Another one is that you can't just lecture at people. You have to tell stories. Stories is how people make sense of the world. I mean, look at all of the Aboriginal and Native societies and how they've, their whole history is told through oral history and through sharing stories and myths and all of that. So we don't want to be lying to people. We don't want to be promoting myths, but we want to be we want to put our science in the form of stories, anecdotes, anything that can make a complex scientific topic more engaging and more memorable. It helps to humanize research. It's important to have an emotional connection with the audience. You've got to look at people. You have to be paying attention to how they're reacting. Another one is that you don't have to. It's best practice to engage in a two-way conversation, which is why, for example, we're going to have a panel afterwards. We're telling you don't ask questions right now just because we want to get through everything, but you have to interact with your audience. Otherwise, they start to snore, and that's really distracting. This one, if I were prioritizing the list, I would have made this number one. Know your audience. And this, a one-size-fits-all approach to speaking with or speaking to any group just doesn't work. You have to be aware of the audience you're going to be speaking to, their age level, their interest level, their education level, their cultural context. And it's just critical to do that. And, I don't want to name names, but one of the plenary talks earlier this week was clearly labeled or clearly targeted at the handful of people in the audience who did the same work as the presenter. And the AAS tells its plenary lecturers that they're going to be facing an audience that ranges from middle school students, and there are quite a few here at this meeting, all the way up to people who have retired from a long career in astronomy. That's a real challenge. That's a huge group, but it can be done to reach them all. Okay, and then number 5 is that you need to trust the messenger. So it helps if you're somehow or another introduced to the group as some kind of credible source. It used to be that any expert was considered a credible source, but now experts are not necessarily trusted just because they're experts. So if you can connect to your audience in some way, I come from here, or I come from nearby, or I've vacationed in this region, or just anything that connects you to them, that takes them to a much higher level of willingness to accept what you're sharing with them. And so, there's many techniques. It's not just one. Oops. All right, let's start again. Oops. Okay, this is one of those things that happens when you switch to Google Slides. Okay, it doesn't matter. You can read ahead. So, emotional appeal versus facts. It's well established that the public understanding of science is not necessarily enhanced at all by just spewing facts. It's analogous to the way that students go through all the way through primary and secondary school learning no science because science was taught to them as facts that they had to memorize instead of a way of interrogating nature and figuring out the way the world really works. Science is a process. But you also need to appeal to people's emotions rather than just to their intellect. And the best way to do that if you're a practicing scientist is to get really excited and share your enthusiasm with the work you do. People tell me on eclipse tours that part of why they get so excited about the eclipse is because I'm so excited talking about it. Okay? Your visuals have to be simple. You can't, we've also seen some examples of slides just filled with text. Bad example. But it happens. You can bend the rules a little. So keep it simple. One illustration per slide, 2 at the most. You don't cram all your stuff and all the captions and everything else onto one slide. Okay. Confirmation bias is something where people tend to integrate into their worldview things that are already consistent with the one they have already. So if you tell somebody that the world is billions of years old, and you just tell them that, and they were taught that the world is only thousands of years old, they're not going to listen to you. So if you want to get that point across to an audience that you think might not already accept it, you're going to have to come up with some strategies other than just spewing facts at them to try to convince them, or at least to get them to think about it. That's all. For me, that's usually just my goal, is just to get people to think about it, not necessarily to accept what I tell them. Context is critical too. Okay, you can't just present scientific findings. You have to give people a reason to think that they're important. Why does this matter? Why is this an interesting thing that I should keep in mind? Or why are you even doing the work you're doing? What is it going to do for the rest of the world? And finally, social media. I'm going to admit I don't use social media, partly because I'm worried that stuff I say is going to end up being used out of context, but it's also because I'm an old fart. But if you're using social media, you have to be really careful, because how you respond to the misinformation that's out there that you know better about, it can backfire on you. So you really have to be super duper careful. It's a blessing and a curse. Okay, so how do we do this? How do we do this? It's easier said than done, right? Thankfully, there are ways to become better at it. Practice is one. Just knowing these things that I've been talking about is another. But if you work at a university or any institution that might have a press office or a public affairs person, or at a lab or any place that does this, there's lots of ways to get some science communication training. And so, professional societies do it. The AAS is not really doing it right now. Part of the problem is that, the outreach staff, the press staff is small, and at the meetings is completely consumed with press conference planning. But there are other societies that do it. The AGU does it, the AAAS does it. So if you're a member of any of those, you can sign up to get some training. Sometimes it's done online, sometimes they send trainers to campuses. Sometimes you go somewhere for the training. So armed with an understanding of best practices, adequate preparation, plenty of practice, that kind of thing, you can end up not being like this guy. Can you read the caption? I can't put it into layman's language for you. I don't know any layman's language. Right? I've put these 10 tips on a handout, which will be on the back table. And I also list a few sources of additional information for where you can learn some more about these topics. Thank you very much.